Our first example of using or making a hypothesis test when you do not know the standard deviation of the population comes from a let's do it 10 point, I believe that is an 8. A new teacher was looking at the amount of time in college that we are studying as freshmen, and they found the mean to be 7.06 hours. Thus, the null hypothesis, mu equals 7.06. And this teacher feels that they actually study more. So when I look at that, when we start to think that they're studying more, we know that we're doing a test to the right. And they selected a sample of 15 freshmen. That's going to be important in calculating our T, or test statistic, and found that they had a mean of 8.43. So X bar is 8.43. And the sample standard deviation is what we know. And I believe I cut it off on this problem, but I think you can look on your textbook and find that. So my null is mu is 7.06. My alternative is I think they're studying more. Is the population normally distributed? Well, again, I cut this off. If you read, it's assumed that the population is normally distributed. Why am I going to have to do that? Because my sample size is only 15. Okay, so it is an assumption. If I don't make that assumption, then we have to use a different test, because I cannot assume to use other things that are not normally distributed on that normal distribution curve. The test statistic, 1.23. You want to check in your calculator how this came about. If you take your calculator and take 8.43, which is larger than the mu, which was 7.06, so it seems like they are studying more. Sample standard deviation over the square root of my sample size. So 15 students studied an average of 8.43, but look at their standard deviation. That's huge. Okay, so if I sketch a picture of this, even though it's not going to use a normal distribution curve because I don't know the sample standard deviation, I still draw this picture because it's very close, and I'm checking what was the chance that I would have gotten 8.43. Well, remember, this is 7.06, and 8.43 is up here. It seems like a lot of difference, but in terms of standard deviations, it was only 1.23 above. So it was above, but is 1.23 with a sample size of 15 enough of a difference to say that they are studying more? Looking at your table and finding the p-value. Well, in order to look this up, we need to realize that we're going to use that table, the t-table on page 668, and we need a degrees of freedom in order to do that. The degrees of freedom is sample size minus 1, which is 14. Looking at my table, I'm going to scroll down to 14, which is right here, and I'm going to go across and find the p-value. Well, to find the p-value, I'm looking up 1.23. Now, it's approximate, will never be exact. 1.23 is between 20 and 10%. So if I scroll across here, 1.23 lands in here. So it doesn't even give me an exact value, but I can tell it's between 20 and 10. So looking on here, I know that my p-value is between 20 and 10%. Okay, if we use the TI-83 calculator, we can actually find that, and there'll be a lecture on doing that here shortly. Okay, are the results statistically significant? In other words, do I reject the null at the 10%? No, I don't. There's not enough evidence because my p-value is greater. It's not significant enough. It's not small enough, not unlikely enough. So at the 10% level, we need to accept the null. In other words, there is not enough evidence to suggest. Make sure you have that word "not" in there. That freshmen study more. Why would that be? Well, if you think about it, the standard deviation was quite large, and there was only 15 in my sample size, which is pretty small. So let's try another one. This has to do with the value of a home. The appraiser is looking at the average sale price per foot is 37.8, so that's my mu. Right now, 37.8 or $37.80, and they're not really sure what it's going to happen here, so it's just wondering if it's differ. So mu is not equal to $37.80. So on a picture, I am looking, is it different? I'm not sure if it's greater than or less than this $37.80. Now, if my price was $37.60, it's different, but obviously not different enough. So here are some values to plug into your calculator. You want to make sure, taking data, that you can find your X bar. So that's when you do one variable statistics on your 83, or you can use the calculator on the internet. X bar is the mean. You want to make sure you take off the S, the sample standard deviation. Applying my test statistic, it is a t-value. How do I know it's a t-value? Because I had to pull off the sample standard deviation. The other thing is, I can use all of this because it is a normal distribution. So applying that, calculating it, the 34.3 minus the $37.80 divided by the sample standard deviation over the square root of the sample size, which I count is 1, 2, 3, 4, 5, 6. Plugging that in my calculator, I find a value that is negative because it is below. $34 is less than 37. It looks to be a lot less, but with a sample standard deviation of 3, is it different enough? And it's actually down at negative 2.45. So it is way down in this area here. So what we need to do then is we need to find that on our t-table. So let's go to our t-table and let's check my degrees of freedom. My degrees of freedom in this case is 5, because my sample size was 6. So I'm going to go to 5, and I need to go over to a 2.45. Because the curve's symmetric, we don't need to worry about right and left here. Because it's symmetric, both tails are going to be the same. Looks like it's between 5 and 2.5%. And it's pretty much closer to 2.5%, isn't it? But what we need to make sure that we do here is that if this is about 2.5%, this is about 2.5%. So when I double that, it looks like it's going to be close to 5%. Now, what a lot of people don't like is that's so iffy. There's not an exact value. We'll find an exact value on a calculator here in just a moment. So are they statistically significant at the 1%? So conclusion, at the 1% level, there is not enough evidence to suggest that prices differ from the $37.80. Now the 1% is very, very small. So to get very, very small, I have to be really sure. Lots of good evidence to suggest that. So in this case, it is not. Now the next lecture will be a calculator exercise in which we will use the TI-83 to actually come up with this value.